Hey everyone, and welcome to the launch of Stora Enso's building concepts for offices. In the construction industry today, most solutions are mainstream, but they create a lot of environmental problems. At Stora Enso, we are onto something big, being able to bring more sustainable alternatives to replace non-renewable materials like concrete and steel. Construction materials account for 40% of global material used in the world today, and 11% of the global CO2 emissions. And these numbers, they are not decreasing. In fact, population growth and urbanizations are increasing the need for more buildings. By 2060, it's estimated that the global housing stock will need to double. So, the market needs new solutions. Solutions with low embodied emissions, solutions that are circular. The world needs a new approach to materials, and wood is part of that solution. Today, we can build higher, stronger, lighter than ever before with a raw material that is completely renewable, a raw material that grows back. But how do we do it? Today, we are launching our comprehensive guidelines on how to build office buildings in wood. With me here in the studio, I have Stora Enso's business developer, Jessica Schüber, and the sales director of Western Europe, Gareth Mason. Welcome.
Thank you.
So, what exactly do we deliver here at Stora Enso? What can we promise our customers?
Well, Stora Enso has been producing mass-engineered timber elements now for over a decade. In fact, we're one of the world's largest mass timber manufacturers. And all of our elements that we produce and components that we produce are made from sustainably harvested forestry. So what we do is we take these trees and then we produce these very bespoke components using the latest in CNC technology. So this is millimeter precision cutting and assembly. And then what we find in the factories is that there's a very low waste, and the very small amount of waste that we produce, we then actually recycle into biomass energy. So it's a very sustainable form of manufacture. We then, once we've made these components, we then deliver them directly to the building site, and they're loaded in the perfect order for the build sequence. So this makes the actual assembly on site really efficient. We've supplied now over 15,000 projects worldwide, and these projects are using components such as Cross Laminated Timber, Laminated Veneer Lumber, both beams and sheets and panels, and also our new products like CLT rib panel components for floors and roofs, also stair components and construction beams. But now we're doing more than that. So rather than just supplying the material, what we're now trying to do is give everyone and offering everyone the advice and the guidance needed to not only make these buildings very efficient in design, but also giving all the key information to make the right decisions for all the key stakeholders. So people like developers, investors, quantity surveyors. So we're not actually building these buildings ourselves, but what we're doing is providing the guidance and the best combinations of these different components to make the building as efficient and as cost efficient as it can be.
Anything to add, Jessica?
Yeah, for an architect, this concept brings you the grids that you can use when you're planning for a wooden office building, and the flexibility regarding the facades. It shows example how to reach a building's building regulation that is applicable for most national building regulations within Europe. The build-ups are uploaded in our digital library called ProdLib, where you can drag and drop the BIM objects directly into your model. For a structural engineer, it provides you the information what product to use. And these are also in our structural calculation program, Calculatis, which is web-based and free to use, and you can be several engineers working in the same project at the same time. Another good thing about this concept is the information it brings regarding services. So the mechanical, the engineering, and the plumbing, called MEP. And it shows how to design these parts in the most efficient way.
To get a quick overview of what we are talking about, take a look at this. Garrett, you mentioned the wood products like the CLT and LVL, and we see the applications here like the walls and the floors and the roofs, etc., and then the concept, of course. But how does it work? We have a screen here with the different parts on. Could you walk us through it?
Yeah, sure. So I'll show you on screen. I think one of the most common design features that we have in modern office situations are completely open plan. And there's a number of reasons for that, but the main one is that these buildings are due to last, over 100 years, and the company's use of that building and also changing companies in that building means that it needs to be flexible internally. So this very much leads to a beam and post design, or a column and beam design. And this allows, this is taking most of the structure, and what that does is allow the internal walls to be non-load bearing, and then so they can be moved around and adapted in the future very easily. So when we look at the columns themselves, these can either be either Glulam or Laminated Veneer Lumber. These are very strong beam elements, and they can also have pre-fitted fixings to them that are very simple and easy to install on site, so they kind of just click together. And not only is that quicker on site, but it's also safer. There's less working at height and things like that. When we look at the floor and the roof elements, previously these are very large spans, so they only used to be able to be done by, say, for instance, concrete slabs or a high number of steel beams. But by using our latest components, the rib panels, so either CLT rib panels or LVL rib panels, these can really comfortably span up to 9 meters easily, and then also a little bit more as well. As well as the floors and roofs, we have the main core of the building, and the core of the building really supplies stability to the building as a whole. And these walls run full height up the building. They can be either cross laminated timber or laminated veneered lumber, and they usually hold the stair core and the lift shafts as well. So the stair components we can supply in time during the build, and they can come as solid pieces, so they're really one crane lift on site and very quick to install. We often find as well that the main services to the building run up the core, and then from that core they're then distributed on each level to around the building. And all of these components can be designed for fire, for acoustics, for thermal. And not only that, they can also be left exposed as well. So they create this really nice architectural timber aesthetic in the building.
Jessica, anything to add to that?
Yeah, in this concept, we have used as much wood as in as many applications as possible, but as little volume as we can. Of course, there are hybrids examples that we are delivering to at the moment. But in this concept, we have been trying to get as low impact on the LCA as possible. So imagine that you can reduce the use of concrete, which is the second most used material in the world after water. It's also material that is responsible for emitting 8% of the world's carbon dioxide. So by replacing concrete with CLT or LVL, we can contribute to a positive impact on the environment, since wood also stores carbon over its life cycle. CLT and LVL is renewable, it's recyclable, and it's reusable. And this office building concept is a cost-efficient way of using wood, and it makes it competitive to concrete and steel.
Coming back to this concept, how does it actually work? Can you break it up for us?
Yeah, well, when we break it down and look closely just at the individual elements, these are all bespoke made. So they can come in various dimensions and shapes and sizes. And because they can combine together really easily, what that does is make it really flexible for designers. In fact, you can pretty much create any structure that you want. And the whole idea of this concept, it provides the tips and advice to do just that, but it means it can also give you the confidence that it's going to be technically applicable, it's cost effective, and also that its efficiency is high in terms of the overall building design. So when we look at each of the individual products, first of all, we have things like, for instance, Cross Laminated Timber, and which is used primarily for walls and floors and roofs. But we also have LVLG now, and this is a new product that is very, very similar to CLT, but it's made from LVL instead, which is an incredibly strong product. And because these can be CNC cut, you can easily add openings and windows and doors and things. When we move to more like the beams and columns, as I sort of said earlier, this is primarily Glulam and LVL, but we can machine these to any length. And not only machining them to any length, we can also add things like slots for steel plates. We can pre-drill holes for beams. And so the whole idea of this is to make the assembly process on site as quick as possible. When we look at our rib panel components, we have CLT rib panels, and this is where we have a thinner CLT panel, but with Glulam beams glued and screwed to the underside. And because these are glued in factory conditions, when the glue cures, it actually forms this really strong composite element, and that means that we can span large distances under high load with very little deflection. And LVL rib panels are very similar to CLT rib panels, except for we're now using LVL beams instead, with an LVL sheet on top, which is glued and screwed. And LVL itself is an incredibly strong timber product. So in terms of its strength to weight ratio, it actually outperforms steel. So we're talking about really strong timber element that's also lightweight. And just to give an example of that, an LVL rib panel doing exactly the same structural job as a concrete slab is actually about a tenth of the weight. So that's what makes it so structurally efficient. So what we do is we take all of these different components and we combine them in ways that make a really highly effective office building design.
Thank you, Garrett. The structural engineers involved in developing this concept were Ramboll. We spoke to Alan Dowdell about the kind of factors that they looked upon when coming up with this concept.
The concept is a collection of about 5,000 calculations that we've done over the last year or so, and it's all distilled into a couple of easy readable pages for anyone to pick up and use and be the guiding hand for a timber office building of any shape or size. The grid is one of the key things that in an office building you want to set out from the very early doors of your design. So we've worked did a lot of information in the background to think what's the easiest way to give information that the grid is suitable for a timber solution. So we've put together a simple chart that will tell you whether the timber grid is efficient or not, and we've worked on that basis. Well, we went through quite a lot of processes of how to coordinate the structure and services, because you want that zone to be in the same area. You don't want your building to go too high and push up costs there as well. Original option was a duct beam, but we thought that's not clever enough. How can we actually get rid of that, because that also has issues with it. So we've devised a system where we have corridor zones for your MEP to be able to sneak around the structure and poke into areas where it's needed. You don't have to go through a structural beam. In terms of height, again, this is a guiding hand for your building stability will be key. We could have done this concept where it's just for one building, but actually we want the concept to be for all timber buildings. So your stability will work either in three forms. Either you'll have the CLT walls, and that can do a certain height. If you're going a bit higher than that, you'll probably change to a braced Glulam bay of sorts. And then if you're really going really high, the likelihood is you can have a hybrid system with either concrete as your core, and that braces the building, and then have a timber frame that can take the gravity loads. The size of a column can affect the area that you have within your office. So it's quite key to be able to very quickly work out how big is your column going to be. So again, we've put some very simple tables together, and instead of relying on the load that, say, an engineer can read off, we've tuned that into how tall is your building. So if you have a number of stories, and you've got a fixed grid, you can very quickly work out the size of your column, and that includes for fire scenarios as well. So you've got an accurate depiction of what sort of area you're taking up with your column spaces. Timber is sort of connections go hand in hand, so you have to do one with the other. They're not a separate item that you can possibly do with steel and concrete. So there are, with timber, generally two forms of connections. You can go down a fabricated route with stitch plates and dowels and bolts and that's quite a traditional way. Or you can follow the proprietary systems that have been developed over the last few years, which are clip in and go, and they're quite fast to erect on site, but they're also more expensive. So we've just done a very high level information sheet within the concept here about, giving people the information. You can go for the fabricated one, and that can save you a bit of cost and a few other issues, or you can do the other, and that can save you time. And then it's up to you as the contractor, designer, whoever you are, to put for your building which one is the right solution for you. For this concept, acoustics comes down to the floor build-up and how you're going to make that achieve a certain criteria. The interesting about this concept, again, it's not for one particular country, it's for many, many different countries. And they've all got many, many different regulations for their acoustics requirements. So the job we had was filtering that down into a performance criteria, and that is sort of a low, medium, high, and then you can pick which one is suitable for your building. And the good thing is we've up with solutions that are still lightweight, and you're not adding a lot of mass into the system, which is sort of counterintuitive to what you may normally do. This is a great start. It will lead you down the path to where you need to go. It's a good starting point. Then the onus is on you to take it and develop it to the next stage and run with it. But if you follow the principles set out here, you're onto a winner. And the likelihood is somehow you don't have to revert and try and start changing things to make things work. You're not forcing the square peg into a round hole.
Alan Dowdall, he speaks early on about the grids used in this concept. That is an important part, I understand. Jessica, can you explain a bit more?
Yeah, using a grid like the one we have in the concept gives us the option to come up with pretty much any kind of building you want, and still know that the building will be structurally sound. So if you look at the grid, there are certain parameters that will work in terms of size, and we have these in the concept. You can see that there's a 6 to 9 meter span on one side and 6 to 7.5 meter on the other side. And this puts you in a safe range. And if you maintain those grids, you can just repeat those grids to form a building like this, for example. And this particular building is one of those that we have in the concept as a case study. So if you download the concept, you can see exactly how the grid works for this particular building.
What about the facades here? Are we forced to use a certain type of facade, or how is it?
No, so the facade has no load-bearing function in this concept. And this means that you can build with most available facade system at the market today. And therefore we can maintain the wide range of building styles that the architect and city planners desire. And it's very important to have an office building that mirrors the location and local setting. And it makes it easy also to get the possibility to push the project through the planning application process. But the other thing is it's very important to provide the correct thermal and energy efficient properties to keep the energy consumption in the building in use as low as possible.
And talking about the architecture, Scott Brownrigg was the architecture firm that was involved with us in developing this concept. And we spoke to Ed Hayden there to see what has gone on behind the scenes and to understand this concept more from an architect's perspective.
For Scott Brownrigg, for me especially, we lead a lot on innovation and a lot on sustainability. So really this concept combines those two things very closely. So the idea of reducing carbon in building fabric and innovating ways of doing that is a really good match for Scott Brownrigg. So I'm Ed Hayden. I'm director at Scott Brownrigg of architecture. The key part of the design is to create many different forms of buildings. So it's very adaptive. So it allows us to create linear buildings, tall buildings, urban buildings, buildings in business parks. So it has that flexibility of approach. So it's not limited, but it solves some of the key problems that you have when designing with timber, which is how do you integrate services? How do you ensure that it's a kit of parts approach, not a series of bespoke pieces to reduce the costs? So we've designed a system which is comparable to steel and concrete in every way, but has all the advantages of the timber product. A key factor when designing office buildings is to ensure that the building floor-to-floor height stays within certain limits, because that means that the external envelope doesn't get expensive, which pushes the cost up. There's a service run around the core, which allows services to be distributed throughout the building without bespoke holes and cuttings into the downstand beams. So what you get is a modular system which is flexible enough to allow you to build almost any type of building. So one of the great advantages of using the timber over steel and concrete is, of course, weight. So the fact that the building has a much reduced weight compared with concrete means that the foundations and the structure behind the building are much reduced. So that gives you a huge advantage in terms of keeping the costs comparable between timber, steel and concrete. The other advantage, of course, is it's a modular system. It's a systematic approach. So it's built in the same way. So it comes to site and it's kind of clipped together on site. So there's a lot less manufacturing or bespoke work on site. So what this allows you to do is to make truly sustainable office buildings. It allows you to build them in almost any form and any plan layout. It gives you the knowledge that service distribution's been considered and worked through. It also allows you to be sure that acoustics and fire have been addressed. It's very carefully designed to use the properties of LVL and CLT, especially the use of LVL rib panels. Now they give a good fire performance, but they also give a great span whilst maintaining a clean timber soffit. So the soffit appearance is really quite attractive and uncluttered, whilst giving you great spans without additional downstand or other timber structures. Designing timber buildings in this way is very straightforward, because if you're using steel, you have to think about fire protection of that steel. It's a big issue. You have to either overclad or you have to use intermittent paint, which spoils the appearance of the steel. So using concrete, it's wet trade on site. It's quite a messy trade, and and it takes time. So the timber system has this modular approach. Yeah, using proprietary fixings, it's a clipped together system which arrives on site incredibly quick to erect, doesn't require further fire protection, and doesn't involve the wet trade. So it's a great way of designing office buildings.
Both Ed Hayden and Alan Dowdell, they talk about different aspects of this concept. But the part about services are in particularly interesting, isn't it? Can you tell us a bit more about that?
Yeah, I mean, this is a really clever way of designing the heating, the ventilation, and the water systems in these buildings. It solves a lot of the common problems that we have in normal building design, where by having this circulation corridor, having a short span, it means that we can get rid of beams in that particular area, and that's where all of the main service runs are focused. And then these feed off into the communal areas. And this is a really big benefit, because what it means is we increase our maximum floor to ceiling height. height, but it also means a thinner floor depth. And that's really important for office buildings because the majority of office buildings are built in dense cities, where a lot of the time they have height restrictions of the overall height of the building. So by having thinner floor systems and a thinner floor build-up, that means that you can fit more stories in that same height, which in turn means that you have a bigger gross floor area for the owner. And obviously, in turn, that means a greater potential future income from rents from that building.
Very important for developers, of course. Anything to add on the services? Yes.
Yeah, this service design is also a big advantage with our concept because it saves a lot of time during the construction site. Mainly because of the setup, it makes it easier to install it. It's quicker for the services to be installed. And the speed of timber construction, less groundwork and foundation, and the overall speed for the following on trades doesn't just allow the building to be completed earlier, so the next one can begin. It also have a quicker return of investment.
Mm.
And that's a huge impact on the overall cost of a project, because investment and funding of these kinds of projects carries rates charged on loans for construction, of course. And by decreasing the overall construction period, the loans are taking for a shorter period, making it significantly saving in the interest cost and charge to the developer and investor.
Really interesting, Jessica. So how does this look like in reality? Wood City in Helsinki, Finland, is a very good example of what can be done with wood. Let's take a look at this.
The Wood City project started in 2010 when SRV, Stora Enso and City of Helsinki came up with the idea that we should build up a wooden quarter in this great area in the south side of Helsinki. So next year we hold an architecture competition which was won by Antti Noiva Architects, and since then we've been developing this true hybrid quarter combining housing, hotel and office spaces.
For us it was an amazing opportunity to design a unique hybrid block to such a unique and important site in Helsinki city. I've noticed that when people are entering to the spaces where the wood is present, it has very strong effect to the people. In interior spaces, we are leaving the wood visible as much as possible. And we are doing it because obviously it creates very comfortable and relaxing, calm atmosphere.
Everything has gone so far very well in this project. We have been efficient with our element manufacturing, delivery and installation at this Wood City office building site.
The whole quarter is planned to be finished by year 2022.
It is more than the office. There have been 2 multi-story apartment houses and they are already there. And then there will be a parking hall and that is already under construction. And then there will be 1 hotel coming to the same block. The main benefits for building with wood are the installation speed, the environmental impact, and mainly because wood is a renewable material.
The material cost of wood is a bit more higher than compared to other construction materials, but then achieving shorter construction time can actually bring up some of the savings. So by using wood and prefabricated elements, we can actually achieve a shorter construction time. LVL is the strongest wood-based material relative to its weight, and we've really gained all the benefits of LVL in this office building. With LVL we have been able to build longer spans with LVL rib panels. Also we have been able to build a high load bearing structural system with LVL columns and beams.
I'm actually really proud of the Wood City project and the design. I personally really believe that wood is a construction material for the future. Beautiful.
So do I believe building with wood in the future? Yes, of course, yes.
I truly believe that with this Wood City project we are gaining the first references the knowledge to build up the wooden buildings in such a large scale in the future as well. And it will be beneficial for our company.
Sustainability and ecological values are rising trend all over the world, and this is a beautiful example of how to build a modern office building from engineered wood product, and in this case LVL. It's great that we now have an office concept based on which we can share and inspire all stakeholders to utilize wood in their future projects.
Wood City is a real live example, and it's being built as we speak. I want to hear more about other references as well, Garrett, but I know that you have some interesting facts about Wood City.
Yeah, I mean, Wood City is a really fantastic example of sustainable construction. If we just take the timber that was used in just one of those buildings, it was regrown in a Finnish forest on a sunny day in about 20 minutes. So that means, by the time people have watched this show, we've already regrown enough timber to make that building again. And that's a real key fact. It's not just about the carbon that it takes out of the atmosphere, but it's also about the fact that it's renewable.
Amazing.
And in terms of carbon, I mean, this building, it removed 3,777 tons of CO2 from the atmosphere. So
How much is that?
I mean, that's kind of the equivalent of around about 1,400 annual car emission journeys. And so, these buildings are not only sustainable, but they're actually cleaning the planet. It's a form of construction that actually cleans the planet rather than producing carbon. And we will talk a little bit more in detail about sustainability a little bit later on, but it's just important to see the key facts of these now.
But then coming back to the question about other references, do we have any other references around the world?
Yes. So as I said earlier, we've delivered over 15,000 projects, but in regards to offices, right now we're currently working on 40 different office projects all over the world. And there are actually some fantastic examples, so I can run over a few of them. This is 25 King Street. So 25 King Street is it's currently Australia's tallest timber office building, and it uses open plan space, so it's around about 15,000 square meters, and it used about 6,500 tons, or sorry, 6,500 cubic meters of CLT and Glulam. And even a building of this size, the timber in this building's regrown in 106 minutes. So in less than 2 hours, the building can be completely regenerated again in forestry. It also received a number of WELL certifications. So not only is the building very beautiful, but it's also very healthy for the occupants to live and work in. And another building very similar to this is International House. This followed a similar design method in the sense that it's a beam and post design with a braced Glulam system around the external facade. And this is actually one of the most sustainable buildings in Australia. It's received the Neighbours 5-star energy rating. So again, it's not just about making carbon neutral construction and the speed that it's regrown, but it's also making buildings that are energy efficient for their entire life usage. And just the final one here, this is a bit closer to home for me. This is in London in the UK. And this is the greenhouse, and this is kind of different because this is actually it was the renovation of a derelict 1960s concrete building, and what they did was added an extra level to the roof, and then they also extended out to the back, and they actually grew this building by about 50,000 square feet. Looking at the carbon details, this is around about 1,000 cubic meters of CO2 that was taken out of the atmosphere. It was installed by a team of just 5 people, and it was built in 8 weeks. So it's about 8-story buildings built in 8 weeks, and we see that kind of speed as typical across all different types of building projects. But probably a key fact here is that since this new extension's been added on, it's actually reduced the overall energy efficiency of the increased the overall efficiency of the building by 50% in terms of energy. It's not. I think these kind of projects are really great to show that the concepts, not just for brand new buildings that are built in the middle of a field. This is these kind of guidelines and advice can be applied to lots of different sites and lots of different types of construction.
You've shown us a handful of beautiful projects and references here, but if the audience wants to look at more of these projects, can they do that?
Yes, we have collected the ones that Gareth mentioned, but a lot of other projects that is both residential, commercial of course, but also educational buildings. And we will post them in our reference library that we will launch in the near future. And there you can find information like where, when, who, what time, which structural engineer was involved in the project, which architect, which
What kind of products maybe?
yeah, of course, what kind of product, the volume, also the stored carbon. So it's a lot of interesting information that you can be inspired from.
But then I'd urge everyone in the audience to keep an eye on storaenso.com and access this library. This concept, though, it has case studies as well. What do they show us?
Yeah, in this concept we have 3 case studies that we look at from different angles. Structurally, with what application fits best. Architectural, bearing in mind the fire and acoustics, but also the MEP. And we have a section for the LCA calculation. And if you want to look more in detail in the numbers that we're providing, they will be accessible, more data accessible at the webpage where you download the actual concept. And we also have a section covering costs, so you can compare this wooden alternative easily with other building materials.
And being the renewable material company, of course, sustainability is one of the most important reasons why we are doing this. But how is the discussion with your customers when you meet them about forestry and building in wood?
Yeah, so let's start by asking, when was the last time you took a walk in the forest?
Walk in the forest. It was a bit time ago.
Yeah, but the last time, do you remember the feeling of peacefulness, the smell of the trees, and also how the fresh air was streaming into your lungs?
You create nice pictures in my head, at least.
So now imagine bringing this indoors, where we spent about 90% of our days. So wood buildings can make that happen. And studies show that people living or working in houses made of wood experience a greater well-being, have an improved ability to focus, but also lower heart rate. So wood building creates healthier living and workspaces. And for the end users, this is becoming more and more known. And therefore, we're seeing an increased interest in building with wood, not just commercial buildings, but also residential and educational buildings. But the well-being of the trees is, of course, essential too, because sustainable forestry creates healthier forests. And for Stora Enso, we work to ensure that more trees are grown and harvested. For example, today in Sweden, we have twice as much forest than 100 years ago.
How come?
It's because the forest owners plant more trees than are harvested. And this, but much more, is what the certifications of PEFC or FSC stands for when you see it stamped on our products.
And I mentioned sustainability as one of the most important reasons, but it's not the only reason, is it, Gareth?
No, not at all. I mean, all of the green credentials and the energy saving advantages are obviously key. But actually, I think one of some of the main reasons why that developers and builders are moving towards this type of construction are actually much more short-term based. So, for instance, not only is the entire build process quicker and simpler, but it's also a lot more accurate. Because we're using the latest in BIM technology and manufacturing technology, what we find is very little errors on site, so less problems to fix. You also find that the site teams are a lot more productive, and the build programs can be a lot more predictable because you know exactly what panels are coming, what day they're going to be installed, in what time. So overall, it gives more confidence in the build program to the main contractors and to the developers. Also, there's pretty much zero waste on site. So we see less skips leaving site, and that means less money just going straight into landfill. It's also one of probably the cleanest ways to construct buildings. It's wet trade free, it's dust free. It's one of the quietest forms of construction. So that means that you can build in really built up residential areas without disturbing the neighbours with being too noisy. And on top of that, for developers, it opens up a lot of new sites because this building material is so lightweight. It means that we can now build on softer ground. It means that we can build above tube lines and rail lines. We can build on top of existing buildings. So sites and locations where previously might have been more difficult to build on can now be opened up with this type of construction. And I think finally, and probably most importantly, more than anything, it's cost competitive. So you have a system that's cost competitive against traditional methods, but it's built in 2/3 of the time. And adding to all the other facts about sustainability and the green credentials, when you add in the fact that these are beautifully finished buildings that people actually want to work in, people, it'd be very easy for the developer to sell in the future because they're so beautiful. I think this is a reason why there's so many more buildings that are turning towards mass timber.
A lot of advantages. Anything to add, Jessica?
Yeah, wood gives architects and developers a new and innovative way of constructing offices of the future. So massive engineered wood in form of CLT and LVL, construction beams and ribbed panel components are completely changing the way of in the construction industry and how it works. So this is a step to guide those who are considering wood to go further and to show how to apply it in their project and how to best combine these engineered wood products in a way for them to achieve the best performance and the value for money for the structure of an office building.
If you are a contractor or developer, you have a whole range of other factors to bear in mind compared to, for instance, an architect. So we spoke to Michael Davis from the Property Development Consultants, JLL, to see what are their main drivers when it comes to wood construction.
The main reason that developers should embrace wooden construction for office buildings is actually multifaceted. It's about speed of construction, cost, and ultimately saving the environment and sustainability criteria. It's a really interesting moment in society at the moment where we're looking at the real growth of consumer awareness around sustainability and climate change. And we're seeing a number of corporate clients of ours starting to drive the agenda by issuing RFPs on buildings with sustainability right at the heart of that, and in fact it's ahead of sometimes location and cost. So how that filters then down through the developer landscape is really interesting because we view wooden construction for office buildings actually as a really smart way to align yourself to sustainability objectives, particularly around carbon neutrality. But also we see this increasing desire from occupiers to use their real estate as a tool to differentiate themselves or rebrand themselves. And actually, it's not new news around this whole affinity with wood in residential and particularly in Scandinavian countries. But actually, there's been this real gravitation towards warehouse style offices. And actually, when you look at wooden frame construction offices, it very much plays to that aesthetic, and the desirability factor is very strong as a result. Now, looking at that in a slightly different light around the construction, it's proven that wood is significantly lighter than steel and concrete. And that's interesting because it then opens up real opportunities to start to develop in locations that perhaps have issues around the ground and subsoil. So, for example, if you've got a site that has been blighted by infrastructure underneath it and the loading capacity of a traditional building has always been too much for that location, wood can actually help to solve that situation. The regions that stand to benefit the greatest in the UK, outside of London, will largely benefit in business park locations, largely because the rental returns are a lot lower than in London, and therefore there's much higher scrutiny around cost and speed of delivery, and also in business parks or science park locations, which are largely in and around greenfield sites. There tends to be a much higher sustainability agenda, both from a built perspective but also from an aesthetic perspective. And then looking at London, it's really interesting because, again, just the nature of London, it's a heavily dense city, and logistics are generally quite tight. And at the moment, wood frame constructions normally top out at about 10 stories. And what we're now seeing is the growth of additions to existing buildings. So there are a number of schemes in London where developers are adding 2 or 3 wooden stories onto existing buildings, and that taps into the themes very much of desirability from an aesthetic point of view, particularly in the city fringe where they're adding on to Victorian warehouse buildings, but also from a logistical standpoint, a lot of sites are very tight, and being able to bring modular constructed parts to site dramatically speeds up the construction process and makes it easier for everybody. There are a number of occupier types that stand to benefit from these new styles of buildings, and for different reasons. Traditionally, it's been the media and technology companies that have often been seen as the pioneers in terms of new geographies and new building styles. That isn't set to change anytime soon, but at the opposite end of the spectrum, we're seeing huge corporates, sometimes in the oil and gas sector, some financial institutions, a whole raft of sectors who are looking to reposition themselves for a variety of different reasons. But the common denominator is they all have now very strong sustainability objectives. We firmly believe that moving forward, pension funds and a whole range of investors will seek to align themselves strongly with environmental and sustainability objectives. And as a result, we foresee that early adopters of this format of construction will benefit through enhanced returns further down the line.
So, we have heard from a structural engineer, an architect, a building developer, and our own experts here in the studio. So let me try and summarize this for you. Why build in wood? For a start, we can see that there are clear benefits when it comes to sustainability and the low environmental impact of a wooden office building. But also, we can be clever with the way we are building so that we can reuse parts of a building when the building's life cycle has come to an end. Wood is renewable, the trees grow back. But on top of that, we see that there are health and well-being benefits. People, they perform better, they are more productive, they're less sick in wooden buildings. It's also faster, safer, more quiet to build in wood when you're on site. It's up to 70% faster erection, and it's up to 80% fewer truck deliveries on site. And this means less traffic and less pollution. We hope that this session has inspired you to explore the concept in more detail. If you have any questions about anything you've just heard, now it's time to start asking. We'd love to hear from you now, and we are ready to answer questions that might have come to your mind during the talks here in the studio. So mail your questions by clicking on the green Q&A button below me now on the right of the screen, and we will answer them as they come in. So please, type away. And while waiting for the first questions to come in, I'll use the opportunity to welcome Matthew Linegar to the studio.
Great, thank you.
Matthew, you're the head of R&D for Stora Enso Wood Products and have been very much at the heart of this concept from the beginning.
That's right, Catherine. Yeah, it's been a really great journey so far, and it's great to be here today and to share the concept more with the users online here.
Yes. I will actually start with a question for you. You have listened now to us speaking here for a while. I have a feeling we haven't talked enough about maybe the tools that are supporting building in wood. Can you just tell us a little bit more about the tools and maybe some of the innovations that actually support this concept?
Yes, of course. So the concept itself is not just the manual that you can download from our website. We've also developed the concept hub, which we're launching today as well, which allows the user to really dive into the building and to explore some of the applications and the parts of the building in more detail. For example, they can go in and they can find out more about the facade systems or acoustics or fire safety, not just in the PDF manual that we can download, but actually interactively here on the concept hub itself as well. And as we develop more concepts in the future as well, we'll also bring those concepts into this environment as well. You're going to create more dynamic content that goes with it. Then we also have some of our existing tools. Jessica mentioned it earlier. We have Calculatus, which is our online design tool used mainly by engineers. And they use this software to help them understand the right size of element that needs to be within the building. It's a great piece of software. We've updated it this year with new features and new languages, and we have a great program that we're planning for next year to bring even more new features for more users and more materials for our users. So a great opportunity to really understand how to design with timber buildings better for our engineers. So we have around about 11,000 registered users for this software now. So really, really very popular. And then what we also have through our collaboration in an R&D lab called HEAL, we are developing proof of concepts of new digital tools and services as well. And one of the great ones that we've been piloting this year is called ArrowTool, which you can see here. And this is a tool that can be used on a mobile device or tablet or even on a desktop PC. And it allows the user to actually understand the difference, audible difference between two different build-ups. So if you're, as a designer, you're not sure what the exact construction that you would like, then you can test two different constructions and hear on a set of headphones exactly what the difference is between the two of them and make a decision in terms of which one you think is best, which is a real revelation or a revolution really in acoustics, whereas previously you were reliant on the acoustic engineer who would show you some acoustic sound graphs. Now, as the user, you're actually able to hear the difference yourself. So really great tool that we're piloting and hoping to commercialize next year. And then around that, we're also developing other tools for our customers who are actually on site. So companies that are installing these buildings. We have our track and trace software and also our 360 software, which helps the installer understand which element goes where on the site and more information about those elements as well. So we have a great roadmap of new tools and services we want to launch over the next year.
Yes. I keep an eye also on the screen here. We have some questions coming in, and we have actually a very classic one. I'll hand this over to you, Garrett. How tall can we go?
Well, yeah, it's a great question. Every year it seems the world's tallest timber buildings. There's a new one comes along every year. Currently the world's tallest is 18 stories. It's around about 85 meters tall. But it can definitely go taller. In fact, there was a study done by Cambridge University, which we supported and gave some materials for their testing. And they actually found that you can realistically do an 80-story timber building. So that's obviously pushing the boundaries a lot. What we really see this market for is the mid-rise sector. So particularly when we look at things like population and the density of cities, this is really sort of mid-range, mid-rise kind of buildings. So you can go very, very tall, but then you start having to look at efficiency and really, really tall buildings we see probably working better as a hybrid system. So using particularly like steel frame with CLT floor infills or something similar. And that way you can build really tall efficiently, but you can get a nice balance of the carbon usage from the materials that you're using. So I'd say it's not about turning every building into timber. It's about picking timber for the right element and the right application, really.
Maybe you could also go for the next question.
Yeah.
What do you think are the major barriers in building with wood? What do you think it should be done to overcome these barriers and further expand wood in constructions?
So for me, it's probably more the product knowledge and the available education that's out there. This is still relatively, when you think of the construction industry, a relatively new product. It's been around in Europe for around about 20 years. It's been around in the UK for more like sort of 10, 15 years. So really it's about educating now. So making tools and all the information available to people like engineers, architects, the developers. And this is exactly what we're trying to do. When you look at university courses in engineering, only a very small section of it is based on timber. So I think as this product grows and grows, which it has been over the last sort of 10, 15 years, we'll see more education in it, and we'll see hopefully more tools like this where it kind of gives the people knowledge that they need to move forward with the design.
Do you agree?
Yes, yeah, I do. Education is obviously a key part of what we need to do to help overcome some of the barriers. There are other obvious ones, acoustics and fire and durability are sometimes the key ones. And certainly this concept doesn't necessarily answer all of those questions fully, but it helps the user understand where they can find out more information to overcome those.
Yes. I'll leave the word with you, because we see that there are quite a few questions coming in also related to fire. One question here, looks good, but how do you make them fire resistant?
Yeah, it is a good question, and clearly, timber is a combustible material, so it's an important part of the design process. And it's important to understand what are the specific regulations in the region or the environment where you're operating, where you're going to build this building, and really then working with a competent fire safety engineer who can determine the appropriate level of resistance that's required for that particular building. So that will vary to somewhat between different regions. And once that's understood, then the designer is able to actually design the timber elements to meet that resistance period. And whilst timber is combustible and it burns, it's very predictable in the way that it burns. So it actually makes it relatively easy for a designer to design the elements to be the correct size.
We have one question about the grids. What do you see as the main limitations of office grid spans greater than 7.5 meters? And now it's a bit up for grabs here. Who would like to?
I'm happy to grab that question. Really, what we see with timber buildings in office environments is that the efficient grid span is somewhere between 6 to 9 meters. Really, that's really where the sweet spot is for the material. You can, of course, increase beyond 9 meters. What you need to be careful then is that the size of the elements that are required to do that span start to have an impact on the overall floor-to-floor height, and therefore the overall height of the building as well, which can add cost. So we believe the efficient range is in that 6 to 9 meters by 6 to 9 meters, roughly, but you can go more. And even if you have a much longer span requirement, then as Gareth mentioned earlier, we can start to look at hybrid construction. So we can replace some of the timber elements with steel elements to increase the span.
Anything to add there, Gareth?
No, not really. I would completely agree. Really, there's been such a different range of designed buildings with lots of different size spans, lots of sports halls, gyms, basketball courts. These are typically quite large span, 9, 10, 11 meter spans. And it's just about having that clever solution, whether it be hybrid or whether it be a certain type of connections to help stiffen the beams. There are ways around it, but definitely in terms of the office concept, really efficient grids in terms of costing and things is sort of 9 meter sweet spot.
And whilst those grid sizes might be smaller than perhaps what the industry considers to be normal with concrete or steel buildings, we have to remember that at least the size of the columns in these timber buildings will be a lot smaller than the equivalent concrete building. So it has less of an impact on the actual environment and the space planning.
We have a lot of questions coming in, and one of them is now, what would you use when you produce CLT and LVL? What wood do you use?
Yep, of course. So in our CLT product, we predominantly use a European spruce. There can be some pine within those elements as well, depending on what we are harvesting at the time. And the same with our LVL product. It's also a spruce.
And these we have mentioned earlier, produced in Central Europe and in the Nordics. We have a question related to the production here as well. Being your production in Central Europe, isn't it that bad for the environment to bring construction material to the UK, for instance?
Not really, because what happens is that the carbon emitted from transportation is actually taken into account when we do the carbon calculations for the whole building. So this is called embodied carbon, and essentially the amount of carbon that is sequestered in the timber or stored or taken out of the atmosphere is far greater than the emissions caused by that. So when we look at the calculation for the whole building, we look at everything, emissions from forestry equipment, from the factory, from the transportation routes, and also the return of the empty run. So even with that all taken into account, it's still very carbon negative. To give an example, there's a 9-story building in the UK that stored, I think it was around about 907 tons of CO2. Emitted was 75 tons of CO2 from the factory emissions, and then another 75 tons from just the transportation. So we're talking sort of quite a marginal fraction of the overall carbon sort of calculations. So that's kind of taken into account. And then also when we're going very far distances, places like Australia or the US, we then start looking at vessels to save the amount of emissions from road transport. And actually all of our factories are linked by a train rail system. So we can actually transport quite efficiently using trains. So we look at the location around the world, and then we try and factor in the most carbon efficient way of producing those and transporting them.
Now coming back to the concept as well. Next question: aside the office buildings, is the beam to column system used for the residential blocks as well?
Yeah, that's a great question. And actually, in some markets, we are seeing for multi-story residential, we're seeing the same frame system being used as we have in our office concept. So that's what I would call a post and beam and plate construction, and then having non-load bearing infill walls. So absolutely, some of the principles behind this concept can clearly be applied in the residential. This concept, at least, the value proposition and a lot of the work is orientated around the market for office buildings, but the principles can be applied to other building types as well.
And then we have a question related to the weather. How do you prohibit rainwater and snow penetration during erection mid and high rises? Even in the just shown Wood City third building, you could see selections in the front facade still open. Why not seal them immediately with prefab material?
Yeah, that's a good question, and it's certainly something that needs to be very carefully managed for these types of buildings. So it's essential for every project there's a clear moisture management plan. And what's key here is to prevent moisture ingress into the elements. And there are some simple ways we can achieve that by applying end grain sealers to the cut faces in the factory. So when they're delivered to site, they have that level of protection already. And also taping joints on the floor or the roof construction that stops the water getting into the joints and then into the panels themselves. And then also, if there is a rain event, we can clear the water should be cleared away as quickly as possible, or allowed to drain off as quickly as possible to prevent that standing water becoming an issue. And actually, with just some of those simple steps, you can significantly reduce any risk of moisture ingress during construction. Yes, you could completely protect the building during the construction. That adds a significant amount of cost. What we find is that if the moisture is managed in the right way during construction, then we mitigate any future problems.
We have a question coming in. What is specifically speedy in the construction process when using wood compared to concrete and steel?
Yeah, happy to take that one as well. I mean, the main advantage here is that the products that we're talking about here are all prefabricated, and that's one of the real advantages here. It brings speed. Yes, you can, of course, prefabricate steel and concrete elements as well, but timber has the advantage of also being much lighter weight. So the elements are easier to install. You can get more elements on one delivery, and therefore you can be more efficient with your lifting of your crane of your elements into site. So prefabrication and the lightweight nature of these materials are some of the real advantages that we get. We have seen also many other advantages in what I call the follow-on trades. So once the timber frame is complete, the trades that come in to fix the mechanical or electrical services or lifts, for example, it's much easier for them to fix into the timber structure than it is into concrete. So there's less noise, there's less dust, there's less time required to do that. So when you add all of those savings up, we see savings anything up to 30% in terms of construction duration.
It also comes down to the accuracy of these buildings as well. In terms of build tolerance, they're very, very small tolerances. So that means that you've got more confidence to do things like order your glazing. At the same time, you're ordering the structural frame rather than having to wait till the structure's built to check overall tolerances and openings. So even smaller things like that can really help speed up that construction process even more.
We have time for a few more questions. How much does it cost per square meter in the building system in timber compared to concrete? Can we be so specific?
From our concept, we've got the 3 case studies where we've actually gone into real detail with the cost study, and this shows the building square meter rates, and it compares them between a CLT solution, an LVL solution, a steel, and a concrete. What we find is it's all very actually comparable within a range of around about between 3 to 6%. And at this sort of feasibility concept stage, that's the kind of price range or comparison range that you would expect anyway in early design. What we find is even though there might be slight differences in the square meter build cost, so that's for construction and design costs, it's actually the cost savings that you get outside of the construction that really make this a competitive way of building. So for instance, if you're a developer and you're doing an appraisal on a site, you'll be looking at the gross development value, how much money that you can make back from this building. And these buildings are very sought after at the moment. So it means that you're probably more likely to be able to achieve a higher gross development value. and also things like you've got less financial risk because there's less errors, and you can be pretty more confident in the build program. There's less financial risk there to be going out of that range. And also, yeah, in terms of the build cost and the build time, because this is a really quick way of building, I think Jessica said it earlier in the show as well, you're taking loans for a shorter amount of period. So that construction time is squeezed, and that's where the biggest loans, the biggest costs are in most projects and most developments. So by having a smaller loan period, you've got less interest to pay, and that kind of financial difference kind of makes the square meter rate sort of less an impact, and in fact kind of insignificant. So we do show in the brochure these comparisons, but it's important to point out that it's not just construction costs that affect the cost effectiveness of the structure.
If we have a short answer, we'll have time for one final question. Is this concept considered for seismic zones?
So in the concept, we don't go into earthquake design as such. So the concept really is setting out the principles for the building itself in terms of the grid, the stability options, etc. So there's no reason that it can't be designed for a seismic region. You just need to know what the load requirements are and design the connections and the elements to suit. So in the concept, we don't define what the connections are. We don't define the exact size of the element. So it's still down to the engineer to actually finalize that design for the region where the building that they're proposing is going to be. So we don't specifically address earthquakes in the concept. It's part of the structural design.
This is what we have time for. Thank you so much for answering all these questions. And thank you everyone for submitting questions and keeping this Q&A session so interactive. We did not manage to answer all of your questions, but we will. And the answers will be published on storaenso.com, where you will also find all the other material related to this office concept and this launch. At Stora Enso, we truly, truly believe that anything made from fossil-based materials today can be made from a tree tomorrow. In fact, we're moving in our own headquarters in Helsinki to a new wooden building, following this very office concept. So it's possible to make a difference, and you can too. So download the concept manual here at the link. And if you have any questions, just get in touch with us directly. That's it for now. Thank you for watching.